Hello everyone. Now we are starting chapter 4. So first is 4.1 graphing polynomial functions. So what are polynomial functions? So before polynomial functions we have to remember what are polynomials. Polynomials are in which we have a more than one term. It's a poly means many, nomial means term. When you have a many terms, it's considered as a polynomial. Okay, and polynomial function, if your function is written in the form of polynomial like an x power n minus 1 x power n minus 1, an minus 2 x power n minus 2, so on, an a1 x plus and the last a naught, a constant term. It's a polynomial function. And what are the properties of polynomial function is the power of n, the power of x that you're choosing, x power n. The n is number at integer greater than equals to 0. N is an integer greater than or equals to 0. Let's write first is monomial. Here it's a consider monomial means it has a one term, binomial it has a two terms and so on. I'm writing the linear first. Linear will be a function is equals to a1x plus a0. Quadratic. Quadratic is a2x square plus a1x plus a0. Similarly, cubic fx is equals to a3x power 3 plus a2x power 2, a1x and a0. What are these a0, a1, an? These are real numbers. ai's are real number. You can add a constant also, constant function. Constant function is fx equals to only a constant number a0. Next, here we have to decide whether each function is a polynomial function or not. If it is a polynomial, write in a standard form. Standard form means you are writing degree in a decreasing order. First will be the highest degree term, then lowest, then go down, down and least one. And what is this? State its degree. Degree means the maximum power of x. Or you can say the exponent, the maximum exponent of x. Then its type. Type it's linear, quadratic, cubic, like that. And leading coefficient. Leading coefficient is the constant term that's multiplied with the highest degree term. It's known as a leading coefficient. Let's start with this A part. In this A, they are saying write in a standard form. It is already in standard form. You don't need to redo it. It's negative 2x cubed plus 5x plus 8. It's a standard form. State its degree. So degree is 3. Type. Degree is 3, so it is a cubic. It is a cubic polynomial function. And then leading coefficient. Leading coefficient. Leading coefficient is minus 2. Minus 2 is the leading coefficient here. Alright, let's try the question number B. You can check, here is a power 3 and here is a power 4. So when I write in a standard form, I will write the maximum power first, power term first, then the next lower than that, and then the least one. It is a gx function. Yes. Standard form done. Degree. Degree is 4. 4 degree polynomial is known as a quadratic. It's quartic. Quartic polynomial. Quartic. Okay. Next is type. Degree, type. The degree is 4. Now its type. Type is quartic polynomial. Then leading coefficient. Leading coefficient is square root 2. So here don't say square root 2 is not an integer greater than equal to 0. The root 2 is a value. A can be any real number. We have to concern with this powers of x. Okay. Now you can check for C. Here x power 2, x power negative 1. Just because of this negative 1, this is not a polynomial. Here x power 2, 3 power x. What is 3? 3 is a constant power x. This is not a polynomial part. In a polynomial, always x power constant, not a constant power x. So this is not a polynomial. Okay. Let's do the next one. Evaluate the function when x is 3. When x is 3 means substitute x as a 3. Where you find x? Substitute 3. It's 2, 3 power 4, 8, 3 power 2, 5 into 3, minus 7. You can simplify. 3 power 4 is 81, minus 8, 3 3 is 9, plus 15, minus 7. You can solve it. 2, 1, 6, 72, plus 15, minus 7. And if you calculate, you will get 98 as the answer. Okay. Let's do the next. Next is end behavior of the function. End behavior. End behavior means we are checking that where function is going if I substitute the value very large. If I use or if I substitute a very large value of x or very small value of x in a very negative or a very large positive. And behavior is depend upon 2. Here I will define the polynomial in 2 parts. Where if the leading term or leading coefficient is positive, and another possible case is leading coefficient is negative. Okay. And next, it can be more classified as a even degree polynomial, odd degree polynomial. Even degree, odd degree. Here also even degree, odd degree. In the even degree polynomial, if the leading coefficient is positive, and even means it's having a same behavior on both sides. Either you choose very large value or you choose very small value, it has a same behavior on both ends. I'm not talking about some finite value. I'm talking about very large values like 1000, 1 lakh, that more than million, that value. So if you go up, it will go up this. Even if you put a negative number, because the power is even, it will change into again positive. Maybe it changed the behavior for some finite numbers, but after that it has its leading value positive from the both sides. Same if I check this in an even degree, if it is a coefficient negative, it will be show downward behavior in both sides. It's like this. Whatever this, both will go down. In the even degree, coefficient is positive, both go up, both ends go up, and in a even degree, coefficient negative, both ends go down. Now, odd degree. In the odd degree polynomial, the behavior is like this. One is going up and another is going down. Odd degree but negative coefficient. Direction change. Where it was going up, now it is going down. When it was going down, now it goes up. So it's like this. Okay, this is how the end behavior is for the given polynomial. We will do a question here to make it more clear. See this. It says graph a function fx minus x cube plus x square plus 3x minus 3. For graphing, I will try to choose some finite values. Then we will use end behavior. X and the function value. Function value is considered as a 1. I choose 0. If I choose 0, I get negative 3. If I choose 1, I'm getting 0. If I choose negative 1, this becomes positive 1, positive 1, negative 3, negative 2 minus 6, negative 4. You can check for one more value. 2. 2 cube is 8. Cube of 2 is 8. Plus 2 square is 4. 3 2 is 6 minus 3. Minus 4 plus 3 is negative 1. Okay, let's try to draw. 0. 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. So first point I'm taking here 0, negative 3. Here 1, 0. Here 2, negative 1. It's this. Then negative 1, negative 4. Negative 1 here. It's negative 4 here. Let's do one more value for negative 2. For negative 2 if you check. Negative 2 cube is negative 8, but outside negative is there, so it's become positive 8. Negative 2 square is positive 4. Negative 6, negative 3. 8 and 4, 12. 12 minus 6 is 6. 6 minus 3 is positive 3. Add minus 2, it's positive 3 up. Now try to connect them. It's connecting like this. And behavior. X is a number, very positive number, very large positive number. So cube of a positive number is a positive. Outside is negative. So positive into negative is negative. So that means your end behavior is downward. If you choose a very large negative value, a very negative value, negative term power 3. It's odd power. Negative power odd is negative. Outside is again negative. It's a positive. So the total function will go up. So this is how end behavior helps to draw the graph. Okay. Let's do the next one. Sketch the graph of the polynomial function f having these characters. So we are using 2, 3, 4 and 0. Let's draw it. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6. First condition is says f is increasing when x is less than 0. For less than 0, it is increasing. Increasing means it's like this. It's going up. It's going this direction. This is increasing behavior. And when x is greater than 4, it is again increasing. Increasing is this. This is first curve you will get. For left side you will curve get after like this. And after 4 you are getting curve like this. Then it says decreasing in between 0 to 4. Decreasing is this curve, going down. Going down is like this, decreasing curve. F of x is greater than 0. Greater than 0 means above x-axis. The answer is above x-axis. It's from minus 3 to minus 3 to minus 2 to 3. So you can check like this. From minus 2 to 3, in between, the value of the function must be above the x-axis. It must be here somewhere. And for this value, it should be down. Okay, let's draw it now. Before 0, I have to move function go up. And if go up, it will be upward above this x value, above this x-axis after minus 2. That means below minus 2 or before minus 2 it was down. After this it's above. It's still above, increasing only up to 0. After 0 it's decreasing, going down, down. It's at 3 it's above the x-axis, after 3 it's below x-axis, go down. After 4 it start increasing again, let's go up. When function value is below the x-axis, when x is less than negative 2, yes. For less than negative 2, it's below, it's downward. From 3 to 5, it's also down. You can take like that. Here we draw it by approximation. As they give you this condition, just because of that, you get a condition like this. The negative value is only in between 3 to 5. Negative mean moves down. Another condition was after 4 it must go up. Before 4 it was going down. After 4 it's up. Here it's going up. After this it's going down. Look at this. Going up, then down, and again up. This is how we draw the graph of the function. Then check what is the possible degree. Degree is check it how many times it cuts the x-axis. 1, 2, 3. And also you can check the end behavior. One is going up, one is going down. So degree is an odd degree. Odd degree, one is going up, another going down. Leading coefficient. On moving right side, the function also go up. Therefore, it's a positive coefficient. Coefficient is positive. Okay, I hope this is clear. Let's do the next one. Used in the United States can be modeled by the polynomial function this. T represents the number of years. When T is 1, it is 2001. Use graphing calculator to graph it. So you can use graphing calculator and you will get graph like this. What you have to do, you can use any graphing calculator like Desmos or GeoGebra you can use. At the first you will substitute 0.15128. You will substitute this equation, you will get your graph like this. Okay. And here then you can in the next column or you will put the limit of the t. T is they want only from 1 to 10. So only that specific graph you will get in that interval. Okay. This was A. B part is what is the average rate of change in the number of vehicles in use 2001 to 2010. If 2001 is considered as a T1, then 2010 will be considered as a T10. I have to calculate average rate of change. So V at a final point minus at a V at a initial point over the total distance. Substituting the calculator, you will get your answer. You will get approximately 4.443. Okay. This is the change. It's not the value, it's a change in the number of vehicles used. In total 2001 to 2010. C part says, do you think this model can be used for year before 2001 or after 2010? Explain your reason. So they are talking about the behavior after these points. After 2010, so they are saying how the behavior of the graph will be. It is a leading term positive. Its a coefficient is positive and the degree is odd. I will say when t is very large, t approaching to infinity. This is the right end point notation. If you are moving right end, a very last point and right end points, if you are moving toward that, your v value is also infinity. It's a positive highest value. Its power 3 is also a positive. Outside is a positive number, so total answer is positive. If you take the negative value, negative infinity, very large negative values, v of t also goes to negative infinity. So this says that after 2010, this value is getting increased. Okay, the number of estimated vehicles will be increased. and before 2001 it was less because it's an odd degree polynomial. If you look at this estimated graph, it will go up, it will go down. We check the end behavior. If I move right side, our function go up. If I move left side, our function go down. It's like this. Okay, so this was 4.1. 4.1 is polynomial graphing. This was important when these conditions are given and you are drawing. Here I can add one thing. If t is approaching to infinity, instead of t, let's x approach to infinity. Where this function is also goes to at this endpoint, we are moving left side. Left side, so x approach to negative infinity, but the function goes up, means positive infinity. Here, when x approaches to positive infinity, function also positive. If x is negative of infinity, function goes to negative infinity. Similarly, you can try to write for this. Okay, I hope you understand. If you have any doubt, you can ask in the comment section. Thanks for watching.